Welcome to the Colaberry AWS workshop video. In this video, we will learn about what machine learning is, the different types of machine learning, and also the related reinforcement learning. Additionally, we will check out basic computer science functions and some neural networks, but these will be optional and featured at the end of the video. Machine learning is defined as a subset of artificial intelligence in which machines find patterns and provide predictions without being explicitly programmed to do so. More specifically, it is a subset of artificial intelligence that includes any techniques which enable computers to mimic human intelligence. A subset of machine learning is deep learning, which is based on neural networks that permits a machine to train itself to perform a task. Now, let us watch a video to understand machine learning and the various different types of machine learning.
Machine learning is guiding artificial intelligence capabilities. Image classification, recommendation systems, and AI in gaming are popular uses of machine learning capabilities in our everyday lives. If we break down machine learning further, we find that these three machine learning examples are powered by different types of machine learning. Image classification comes from supervised learning. Recommendation systems comes from unsupervised learning. Gaming AI comes from reinforcement learning. How can we better understand supervised, unsupervised, and reinforcement learning? Let's start with supervised learning, which makes up most of the uses for machine learning today. In supervised learning, the machine already knows the output of the algorithms before it starts working on it. The algorithm is taught through a training data set that guides the machine, and the machine works out the steps from input to output. Supervised learning is used for image classification or identity fraud detection and for weather forecasting. But how is unsupervised learning different? Well, first off, with unsupervised learning, the system does not have any concrete data sets, and the outcomes are also mostly unknown. Now, when you log on to Hulu or Netflix, you have personalized recommendations because of unsupervised learning. And lastly, there's reinforcement learning. Reinforcement learning is different because it gives a high degree of control to software agents and machines, which are determining what the behavior within the context should be. People are helping the machine to grow by maximizing performance, providing feedback to the machine, helping it to learn its behavior. Reinforcement learning requires the use of tons of different algorithms, giving control to the agent as they decide the best action based on the current results. When you are gaming on PC, Xbox, PlayStation or Nintendo, and you witness AI in gaming, this is because of reinforcement learning. Now that we understand supervised, unsupervised, and reinforcement learning by breaking down machine learning, what are some applications of these forms of machine learning? Look at these examples of supervised learning. And check out these examples of unsupervised learning. And here are some examples of reinforcement learning. Applications for machine learning are endless and constantly expanding. Thank you for joining me.
We will now talk about reinforcement learning. Reinforcement learning is defined as a machine learning technique where an agent, which is the component that is responsible for making decisions, explores its environment to learn how to perform desired tasks by taking actions with predefined good outcomes and avoiding actions with predefined bad outcomes. A reinforcement learning model will learn from its experiences and over time will be able to identify which actions lead to the best rewards. Let us look at simple examples to build on the understanding of reinforcement learning. Reinforcement means the process of encouraging or establishing a belief or pattern of behavior, especially by encouragement or reward. Let us use the example of training dogs. A dog learns by associating actions, such as bringing back a toy to its owner, with getting a reward, such as verbal praise, like good dog. Another example would be of a maze. You are the agent who is trying to complete the maze, which is the environment. Walking is the action that you perform on this environment. The nearer we are to the maze exit, the more confident we are that we are making the right decisions. This acts as a reward. The agent tries to perform the action in such a way that the reward is maximized. This is how reinforcement learning works in a nutshell. In reinforcement learning, an agent interacts with an environment with an objective to maximize its total reward. The agent takes an action based on the environment's state, and the environment returns the reward and the next state. The agent learns from trial and error, initially taking random actions, and over time identifying the actions that lead to long-term rewards. In this diagram, I represents the current state, and I plus 1 would represent the next state or the next future step. An example would be a time I, we have the agent performing an action, AI, based on its present state, SI, and reward, RI. Based on this action, the agent have moved to a new location in the environment, I plus 1, which in turn gives it the feedback of the reward, RI plus 1, in the new state, SI plus 1. Now we will give a quick recap of the major points we've covered in this video, which were: machine learning is defined as a subset of artificial intelligence in which machines find patterns and provide predictions without being explicitly programmed to do so. That there are 3 types of machine learning: supervised, unsupervised, and reinforcement. Then, in reinforcement learning, an agent interacts with an environment with an objective to maximize its total reward. The agent takes an action based on the environment state, and the environment returns the reward and the next state. The agent learns from trial and error, initially taking random actions and over time identifying the actions that lead to long-term rewards. Now, we will learn about functions in Python. These are optional in case you already know the basics of Python programming and functions. A function is a block of code that executes in a sequence and can be invoked in a repeated fashion. In Python, as in other languages, users can define their own set of functions such that a set of statements can be invoked multiple times from other parts of the program. There are various parts to a Python function which are taught in depth on the Python for Data Scientists course presented at the Refactored AI website. We would recommend you to visit the course and select the Libraries and Functions module to learn more. The last topic of this video is neural networks. Let us see what a neural network is and how it functions.
When you or I look at this creature, we know it's a dog. But when a computer sees him, all it sees is this. How do I get a computer to recognize that this photo, or this one, or that one, is a photo of a dog?
It turns out that the only reliable way to solve this problem is to give the computer lots of examples and have it figure out on its own the average, the numbers that really represent a dog.
Here's where deep learning comes in. As you might recall, it's a program based on the way your brain works. And it looks something like this. Here we have layers of sensors or nodes. Each feeds information in one direction, from input to output. The input layer is kind of like your retina, the part of your eye that senses light and color. In the case of this photo of Buddy, it senses dark over there, light over here. This information gets fed to the next layer, which can recognize basic features, like edges. That then goes to the next layer, which recognizes more complex features, like shapes. Finally, based on all of this, the output layer labels the image as either dog or not dog. But here's the kicker, and this is what's revolutionary about deep learning and neural networks. At first, the computer has no idea what it's looking at. It just responds randomly. But each time it gets a wrong answer,
information flows backwards through the network saying you got the answer wrong. So anybody who was supporting that answer, your connection strength should get a bit weaker.
and anybody who is supporting the right answer, their connections get stronger. Back and forth, it does this over and over again. Until, thousands of images later, the computer teaches itself the features that define dogginess.